Good afternoon, Physics 40S. I have another lesson here for you today. It's still based upon equilibrium forces. We're going to be taking a look at a slightly different situation now. I have a setup here, as you can see. This is an example. Like, let's say you have a laundry line at home, and you happen to be a kid, and then you hold on to the laundry line and it bends down like this, right? And this is just the horizontal line so that we can reference that this side of the laundry line is at 20 degrees and this side of the laundry line is making a 45-degree angle. So obviously you as the kid, you're not smack dab in the middle of the laundry line, you're a little closer to one end. And what we want to try to do here is try to figure out what the tension is in these lines and also the mass of the kid. I have to give you a little bit of information before we can actually start with that. We're going to say that this is tension 1 over here on this side, and on this side we'll say is tension 2. Now normally I subscript the 2's and the 1's, but it's a little hard for me to do that in this program, so just please make sure that you make the 2 and the 1 a little smaller and lower down. And the information that I'll give you is that this tension right here, T1, is 200 newtons. So you can kind of write that in terms of some of the information that you know, that this side over here is 200 newtons. Alright, so what we want to do now is to try to figure out what this tension over here is, and then also the mass of the kid. Just make that a little smaller so that we have a little more room here. And with this kind of question now, what we need to try to think of is how this all balances out. We've sometimes broken things up into X information and Y information. But it's helpful here, first of all, to take a look at what the forces are occurring in this situation and collect all the X forces in one equation and all the Y forces together in another equation. So if I draw in just basic force lines, obviously we've got the force of gravity over here. Whoa, that is a huge arrow. That is absolutely massive. So let me just change something here. Let's go back to this kind of look. Okay, let's try that again. So we have the force of gravity, obviously from the kid pulling straight down. We've got tension 1 going exactly along this laundry line in this direction. And we have tension 2 going along in this laundry line over here. Okay. So again, this you can see it definitely has an X direction and a Y direction. This has an X direction and a Y direction. But this is purely just straight in a Y direction. There's no X in that one at all. So these three forces have to balance out. What this also means is that the two X forces have to balance out, because there's one X over here and one X over here. And the three Y forces have to balance out. This Y force, this Y force, and this Y force. So it's as if we've actually got two main ideas that we have to consider on this problem. I'm going to try something new on this program that I found. So if it's a little slow, bear with me, but it allows me to actually type out equations rather than drawing with my finger, which is a little cumbersome. So bear with me here. So the two ideas that we've got is that we've got, let me just try something here. Maybe I can't do this. Hold on. Oh. Hold on. Let me try this again. Okay. We have tension 1 is going to equal, oh, hold on. Let me start this all over. I apologize. Let's try this again. See if I can move this to this side right away. Okay, here we go. Like this. Go back into editing. All right. We're taking a look at just the X information here. So we have tension 1 in the X direction. So T1X. This is going to equal the other X direction tension. So that's going to be then T2, T2X. There we go. So this X force has to equalize this X force. All right, so there we've got one. So then we're going to do the same idea with the Y's. This Y and this Y are both pulling up. This Y is pulling down. The X's, technically one's positive, one's negative, but we can see that whatever this one's pulling to the left or in the negative direction has to equal the same value this one is pulling to the right. So let's do the same thing now with the Y. This is pulling up, this is pulling up, this is pulling down. So this up and this up together must equal this down. So let's see if we can put that in. Move this over here. Go back into editing. All right. So now we're going to have T1Y is going to equal hold on, not equal, plus T2Y, those two together are going to equal the force of gravity pulling down. And if you remember, we call that Fg. So that is force of gravity pulling down, Fg. There we go. Okay, so we've got our two main ideas now. These two forces have to be equal. These two together must equal this force. So the mass can only be found in this equation over here. It has to do with Fg. The mass can't be found over here. So this isn't going to help us to figure out the mass of the kid. So we're going to have to probably try to figure out T2 first. We can see that there's a T2y over here and a T2x over here. So both of these have a relationship to this force here. But we don't know what the force of gravity is, so we can't figure this out without having this. So we really got to work with the x direction first. So this, what we're going to do is we're going to change this into the cos ideas. So let me write that out, what that's going to look like. All right, so another math equation. All right, move this over here. Go back into editing. So just like what we kind of did with projectile motion, we would sometimes find out what the x direction was in one simple equation. We're going to have something similar here too. Remember that the x direction deals with cos. So what this is going to look like is that we're going to have T1 cos, and in this case of 20 degrees. That right now is the same thing as T1x. So T1 cos of 20 degrees is really T1x is what we're saying. And then we can do the same thing with T2x. T2x is the same thing as saying T2 cos of 45 degrees. So now we've got the idea that this T1 cos 20 is the same thing as T1x, because that's really what it is, and T2 cos of 45 is T2x. And since I've given you that T1 has a total tension of 200, we have this exact part of our equation. The only thing that we don't have left is then T2. So now, which means we've got to plug in our values, chug through the mathematics, and we'll actually figure out what this force is here. So let's do that. Okay, see if I can move this. Here we go. So now we're going to have T1 is 200 times the cos of 20 degrees, and this will equal T2 cos of 45 degrees. There we go. So if we punch 200 cos of 20 into our calculator, we'll get that that's 188. And then this will equal, again, we have on the other side, we don't know, T2, T2, and it's probably easier actually to leave this as cos of 45. You could change cos of 45 into a decimal if you want, but it's probably just easier to leave it like this. And so now what we need to do is we just divide the cos 45 to the other side, and then we'll get T2. So let's do that. We're going to get T2 equal to, and now we've got a fraction, 188 divided by the cos of 45. There we go. And so when we punch that into our calculator, we're going to get that T2 will equal, nope, that's not what I want. There we go, will equal 266 newtons. There we go. We just came up with one of our answers. So we can put a little box around that, yep, this is one of our answers right here. Good. So now, since we have that this is 266 newtons, we can enter or insert that value into our T2y. We can get T1y, and now we can figure out the force of gravity. And if we know force of gravity, we can get the mass by dividing by 9.8, which is the constant value for gravity. So the work is going to look similar to this, but instead of the x direction using cos, the y direction is going to use sine. So this will look very similar here as it is here. We just have this extra term of fg. So So let's start putting that information in. No. Oh, and I don't want red, I want black. There we go. Okay. So T1y is the same thing as saying T1 sine of 20. And then we're going to add T2 sine of 45. And this will equal, and if you remember, Fg is saying the same thing as mg, mass times gravity. Good. Now we can just start entering those values actually in to our item. Let me try something here. Oh, look at that. I just pasted it. Sweet deal. So let's put in our value for T1y, or sorry, T1. Our T1 was 200 newtons. Our T2 that we figured out before was 266. There we go. And we also know that gravity is equal to 9.8. And so we can enter that in as well. Okay, let's do the mathematics that we can. Let me see if I can copy. Yep, paste. Perfect. Look at that. Oh, that's way simpler. Okay, 200 sine of 20. That will actually give us a value of 68. And 266 sine of 45 gives us 188. And we can just change these around and put 9.8 m, because that's the same thing. All right, now this looks like a simple equation. We need to add the 68 and the 188, of course, and then just divide by 9.8 on the other side. So our new equation will look like this. That the mass is going to equal 68 plus 188 is 256 divided by 9.8. And then we punch that into our calculator and we get that the mass is going to equal 26.1 kilograms. Excellent. There's our second answer. So 26.1 kilograms, you multiply that by 2.2, you're over a 50 pound kid. So that's a fairly heavy child. You know, I think my daughter is around 50 pounds right now, so that sounds about right. Yeah, so hopefully this kind of lays out for you a little bit of what you need to do. So again, we started off by just taking a look at the forces here, understanding that the two x's have to equalize, they have to balance. So that's what we said with this equation. And the y's all have to balance. That's what we said with this equation. We know that the T1x has to deal with this times the cos of the angle. And so then we just use that definition to go through. And we did the same thing with the sine, that sine deals with the up and down. So hopefully this helps you. And tomorrow being Wednesday, I don't think you guys have class since it's a half-day PD. So then we will see you again on Thursday. Mr. Entz will give you guys a couple of assignment items to work on that's based upon this. It shouldn't be quite as many as last time, but I need to just finalize that. I will ask him to send me an update to see if it makes sense to give you guys a little bit of extra time then on Thursday to work on these questions, or if it just makes sense to do another lesson or maybe just a shorter lesson. All right, hope you guys are doing well, and we'll talk to you soon. Bye.